Here in this video, we are solving a problem. The problem is like this. A gas bubble radius is doubled by the time it rises from the bottom to the top of a water pond at constant temperature. What is the depth of that pond? That is the question, right? At bottom of a pond at constant temperature to the top. So what is happening here? How do we draw? How do we draw the diagram? Is there's a water pond like this. It is all full of water. That's a water bubble at the bottom. It is rising from bottom to the top. By the time it has reached to the top, its radius is doubled, right? That means if the radius here at the bottom is r, on the top radius is 2r. This all happened at a constant temperature. What is there inside that gas bubble is gas. Therefore, this is about gas law at constant temperature. As per the Boyle's law, pressure into volume is constant. So pressure into volume at the bottom equal to pressure into volume of that gas bubble at the top. So what is the pressure at the bottom? Here there are two pressures. One, this is open to atmosphere, therefore there is an atmospheric pressure P0. There is water on the top of it. So that water also applies some pressure. So the total pressure when you are at the bottom is two pressures. One is pressure due to the atmosphere and pressure due to the water. Pressure due to the water into volume at the bottom. 4 by 3 pi r cube. When it comes to the top, there is no water on it. Therefore, there is pressure only due to atmosphere. That is P0. And volume is 4 by 3 pi. As per the given problem, when it comes to the top, radius is doubled. Therefore, 2r. So if you can cancel, of course, this 4 by 3 pi and 4 by 3 pi. If you simplify this, pressure due to the atmosphere plus pressure due to the water of r cube equal to pressure due to atmosphere 2r whole cube is 8r cube. R cube and r cube can be cancelled. So pressure due to atmosphere plus pressure due to the water is 8 times of atmospheric pressure. So pressure due to the water is 8 times of atmospheric pressure. This will become minus on that side. That is 7 times of atmospheric pressure. So one thing that we have identified by this time is pressure that is there for a certain height h has created a pressure that is equal to 7 times of atmospheric pressure. How much is that height? Let us try to find out using a basic definition of the pressure. As pressure can be written using a formula HdG. For example, we know 1 atmospheric pressure, people call it like P0 is approximately 1.01 into 10 power 5 Pascal. That 1 atmospheric pressure, if it has to be given by water, if that has to be generated by water, I can write the pressure formula as HdG. If it is for the water, I can say height of the water, density of the water into G. So pressure, you have found it as 1 atmospheric pressure as 10 power 5 Pascal. To generate 1 atmospheric pressure, how much height of the water is required, you want to find out. Density of the water is 1 gram per cc or 1000 kilogram per meter cube. G is approximately 9.8 meter per second square. I have rounded it off to 10. So 10 power 5 equal to height of the water into 10 power 3 and 1, 10 power 4. 4 and 10 power 5, 10 power 4 will be cancelled. Then the height of the water, what is remaining is 10 in SI system, 10 meters. So what we have understood is to get 1 atmospheric pressure, we need water of depth 10 meter. Now we need 7 atmospheric pressures as per the problem. That implies to get 7 times of P naught, we need water depth of 70 meter. So for a bubble to rise from the bottom to the top so that its radius becomes double, the depth of that lake shall be at a height of 70 meters. Be careful, this is all valid when the temperature is a constant. That's how we can solve the problem. That's it. Thank you for watching.